the session. Okay, now in previous session we had discussed about the list interface. Its implementation class is ArrayList, and we have covered a lot of methods regarding this ArrayList method, right? See, in general, right, if we are implementing a list interface with the ArrayList, right, all the methods available in this method are accessible to implement here, which means if you implement the list with ArrayList, right, then you will have this. Some methods are available. What methods are available in this list interface? We can implement our collections using that methods. However, in ArrayList, we will have some more methods. If you want to get access those methods, right, you can directly create object with ArrayList like this. Also, you will have more methods, right? It is something like a normal interface, right? A class implement a normal interface. Then if a class implement an interface, and if you give a reference to that interface, what you see, you could access only the methods in that interface. The same way, list is interface with ArrayList is implemented this interface, then you could get access to this list interface method. So that's what we discussed. And also we have seen many methods like set, add, remove, and all these things, how many ways we iterate this list. And next thing is the list interface implementation is vector. Vector is also one of the class which implement this list. You see this one? There's nothing changed here, no error, right? Vector and ArrayList both have the common methods, both have the same methods, most of the methods. And then we'll see that in the next program. Instead of disturbing this one, let's go back to the theory first. What is the vector? Vector also is similar to the ArrayList. Vector also provides resizable array. It is also implementation of the list interface. And most of the methods are similar to ArrayList. What means a vector is resizable array in sense a vector can be dynamic array that automatically grow or shrink on its own, which means that vector will grow when more elements are added to it, like ArrayList, and will shrink when elements are removed from it. But difference here is vector is synchronized. That is, all the methods in vector are marked synchronized. Then thus, once the method is invoked, right, until that method is executed, unless the previous call has ended this, then the method cannot be invoked. See this one, if you go to the class and see this, all the methods in that vector are synchronized as we are saying this. Okay, let's say vector class. Okay, go here. You could see this method, copy into it, synchronized, then synchronized void, right? Almost most of the methods are synchronized. Int capacity, size, boolean, everything, right? Or most of the methods are synchronized. That is the reason we say vector is synchronized, which means all the methods in the vector class are synchronized. But the same thing, you see, this cannot be in the array list. For example, now let's take here as list is interface, and array list we see now. Array list. Now go back to this array list and say this, any methods are synchronized here? No. Now let's take one method here, index of. Okay, search here with the index of. Okay, sorry, no, it's not a method. Say this synchronized method. Okay, is empty. We'll take this is empty. Synchronized method is size any methods. Could see which method is synchronized here. Let's take okay, is empty is synchronized, but you could see here this is not synchronized, and size also, int size is not synchronized. In case of vector, you could see it is synchronized, which means all the methods in the vector class are synchronized. When any class that work on the vector, that act on the vector object, right, anything, then it will not release this until we that method execution is completed, which means if the method invokes for the current call, then that will not be invoked until that current call has been ended. Means if we enter into some method like size is empty or add something wrong, right, which of the methods are synchronized, then it other thread will not enter into that method, and other thread will not be able to invoke that method until that method call is executed successfully. So this is the only difference, and it will grow and shrink dynamically. And major difference is synchronize. All the methods are synchronized. Synchronize, we are talking what synchronize? It is a thread safe, which means every method is synchronized, means the vector object is completely a thread safe. When one thread is working on the vector class methods, that it will never give a chance to another thread request to enter into the same method. That's why we call it as a thread safe. Synchronized by default, all the synchronized methods are thread safe only, right? When we are applying a synchronized keyword in the sense, make sure the request will be made as synchronized, means one after the other. Then that is the reason we say that vector methods are synchronized. So all the methods are synchronized in the sense, then vector object itself is a thread safe. That is the main difference. Which means at a time only one can thread operate on the vector object. But if see performance wise, if you think that ArrayList more faster than the vector, which means multiple threads can acquire, multiple threads can call the ArrayList object, which means multiple threads can operate on the ArrayList object. It means those methods are not synchronous. If the methods are not synchronous, means then it is not able to control. Means any thread, any number of requests come and act on that. So here process is quite fast, and in the vector it is not happen. It will not happen because the performance is slow. Because performance is slow in the sense that it is synchronizing one by one, right? So if is processing the request one by one, once one thread by thread, only one thread at a time, then the performance will be degraded compared to the RList. But however, synchronization process is the main important in the multi-threading programming. If you have a multiple threads which wants to work on this particular object, right, then you will have this vector used in our application. If you use a vector, then if you have a multi-threaded concept, then it will be more helpful. So wherever we have a multi-thread concept, we use vector class to synchronize your method calls. So when somebody asks that when we go for vector and when we go for ArrayList, right, using ArrayList you can store and access data faster. Means if there is a requirement want to just storing and accessing, means just read only purpose, as we discussed in the previous section. If you want to access fast read only access, and no matter right, if whether it is thread safe or not, then we go for vector, sorry, ArrayList. If you want to make your calls as synchronized, then we go for vector class. So that is the only difference. But coming to this programming hands-on, we'll see that what is the difference in our programming implementation. Let's see now. Here we have an exception. That let's forget about these exceptions right now. Now okay, you see this, all the methods in this ArrayList and vector are same. You can add the methods, right? We can add element using add method. You can remove using remove also. That's now another difference is that, right, just now we told, right, if we use vector class directly, what happened, right? Then you have a extra method add element in the vector class. You could say this one, right? I have a add element in the vector class, add element. However, in the list interface, you don't have that. That is the reason you could see the exception. If you go to the list interface and search for this add element, no, you cannot find it, right? That isn't. It is as good as you are implementing a interface which you can use only the methods available in that interface. If you directly go to the vector, right, you have more number of methods available. You can, right, utilize all those methods. If it is a requirement that if you want to utilize all the methods available in the vector, then you can go directly creating of object like this. And if you want to give control to access only limit number of methods, just adding and removing, and right, limit control, then you go for interface. So that is a difference. That now you see this, by creating an object of this vector class directly, you will have additional methods. That's what we are saying, that additionally vector have add element. Add element is equivalent to the add only. There is nothing. If you say add element or add, both are same. If you just look at this one, what we are sending is adding the object element, and mode count plus plus means when we are adding a new element to this vector, then it will increment the count meant to store the next value. Then you can see this again, it is say you are sending a element. What is the difference of this one, right? Add element, and also it is passing this element only of type object. But if you see this add, it also element of type add. There is no difference of that, but add element of this. Now next two methods are, if you want to access the first element, what we do in case of array list, right? You pass the index and right, and get the value, like array list dot get the element for that index. Now here we have the flexible methods are there. If you want to get the first element without knowing the index, then you could get the first element of this. What is that first element? You could see now, after running this program, see this, it is the first element is the element tiger. Sorry, what is happening? Okay, you see the first animal is tiger, and the last animal in this I have added is deer. So this is how you can access the elements from the vector using first and last element. Iterating vector elements is same as array list. Means you can achieve using for loop, and you can go by using iterator. You can also have one more method, right? For loop into int I equals to 0, I less than, then you say vector dot size, and you can say I plus plus. This is our normal for loop. Then you can get that vector dot, sorry, vector dot get. Again you have to pass the index of that. You could see it now, you'll be getting all these things. So it is exactly same as the array list. However, it is synchronized, whereas array list is not synchronized. Why synchronized? Since it is a thread safe. Vector is a thread safe, where array list is not synchronized. If it is not synchronized in sense, then that is not a thread safe. Any class that is not synchronized is not a thread safe, and any class, any object that is synchronized, then that is a thread safe. Means if you are synchronizing the calls, means then your calls are thread safe, so that the result will be adequate. Say if you, when you go for vector, means if you have read write operations, right, adding, removing, then you go for vector. If you have a requirement just accessing and storing elements, then no need of updations, no modifications, then we go for array list, and that is used for faster accessing of data. Means it will help you to retrieve the data fastly. In general, the scenario is that if you have a bank statement, right, then if you want to see the history of your bank records, real-time records, then what you could say is that array list can be used there. Means it is not update, right? It is read only purpose. You just view that and sort by date or sort by name and sort by transaction status according to that, right? So you just view the data. That's view only. Then that scenarios you go for array list. And if you have modifications, more frequent modifications, adding, removing, and retrieve, right? Then we go for vector. That's all the main differences. And what is the next another class which implement the list interface is, so we'll discuss one more here, stack again. Basically this stack is also a class but it is not directly implementing the list interface. This stack is a child of vector. If you see this program stack, right, create an object, you see this one, it is extending the vector class. It is a child of vector class, as we seen in the previous right. You see this vector, you see list implementation classes are array list, vector, linked list, and stack is where stack is the child of vector. So this is one of the collection that we used in our Java programming. What actually stack is, like, stack behaves in a way that it takes the element and retrieve the element like other list collections also. But how is it different? It is like follow the algorithm as first in, last out. What is first in, last out mean? The element which is placed first will be picked at the last element. For example, now you could see this. We have a stack created like this. For example, this is the stack. Now, at first, what we do, the element will be inserted here, first element, and second element is inserted here, and third element is inserted here, and fourth element and fifth element. Now, I have stored the elements in this stack. Now, the first element is there in the last location. How do I access? You cannot get access this element. First, you have to get this element out, which means the last element which you added, that will be picked out first. That's the reason we say last in, first out. First out means whichever the element you inserted last, that will be picked first. Whichever the element you inserted first, that will be picked last. So this is how the stack will work. So this guy will be have disadvantage. Don't go unnecessarily this stack. Whenever it is required, then you can go that. Now, well, how this stack works, right? We have the same method. It's not like add, it is a push, because we are pushing the elements to the stack, right? Let's say push 11, 33, second, third, fourth, fifth. Now we say, if I pick the element, well, what is right? To get the element of this, they say yes dot pick. What will happen? It will pick the element of whichever is last, right? As we discussed that last in, first out. Now you see this one, which element will display here. Now int n we display pick is used to get the element. Which element we got this? 91. With 91 is the last element that I have added in that. Now pop. Pop is used what? To pop the element, which means to remove the element from the stack. Push, pop are opposite. If you push the element, then using pop, you can remove the element from the stack. Now you see that pop also, how it happens. The first element, last element will be pop up first. Now the last element is 91 is the last element. If I say just yes dot pop, then this guy will be go off, and you could see only these guys 18, 145, 13, 11. Since there are 11, 13, 145, 18. So this guy will pop ups. Again, if I say yes dot pop, so now what happens this time? You see now two elements got popped up. See now 11, 13, 145, which means this is the last element. After that, again, this is the last element that we have added. Now this is the first element. It is a bottom, right? Whichever the element you added first, that will go in the bottom. And this is on top of 11. This is on top of 33. This is on top of 145. This is the first element that is displayed in the stack. If you remove this, then this is the first element that need to be picked up. And if you remove this, and the next will be available. This one. This is how the stack program works. And next thing is the linked list. You have this, the linked list is one of the implementation for the list interface. You see this one, you will go back to the same list interface and see this list also is same as our array list. This is also one of the dynamic data structure. This also increases the size when you add elements and decreases when you remove the elements from this list. But this linked list, the moment we say linked list means it is linking the elements from node by node. Means this linked list are stored in a form of containers, which means the list hold the link to the first container, and the first container will give the reference to the next container. That is called as a linked list. Means this list is created with the link from one node to another node. How it looks from, you could see the diagram. This is the first one, we call it as a head, and last one we call as a tail, right? And between we have n number of nodes. Now the first time when you add element, then the node will be created like this. Then there is no previous element for this head, right? And the first element and the next element, if you don't have the element, right, if there's only element in your linked list, then it does not have any pointer. Then this will be look like this. If I add one element, right, 5, then a pointer will be created, right? Then it point to the next node. Means this guy have the reference to the next node. Means this guy, after this guy only the element 5 is added, so this guy has a reference to this element, next of element 5. Now this is the value, this we call as a element reference, and this is the next is again this next having a reference to the next element. Like that, it is holding this 3 parts of data. And list holds the link in the first container which does not have any reference, right? And list which hold in the last element does not have reference to the next. You could say this one, the difference is opposite to the head and tail. Whenever you add an element to the list using add method, every time a new container gets created and that get linked to the next. Now at the first we have the new container, and the moment I add a new element, then that time this is not there, and when every time when you add a new element, a new container gets created and a reference to the previous node to the current node will be pointed. And coming to the methods, array list and linked list, you see that few that physically and largely the methods are remain same for both linked list and array list. But however, the data it is creating in this structural format. It is creating the data in this format with in the form of containers which hold a link format. That is called as a linked list. It is linking one node to another node. Let now you go back to see the I change this array list to linked list, and you could see there is no error and all the methods that we have it remain as is. We could not see even a single error also here. Receiver, all the this list is implementing this array list only, right? Which means no matter what it is, array list, linked list or vector, but if you use extra method which is not there in the list, that situation only you could see the error. Now I'm implementing the list interface, right? This linked list is implementing this list, but however all the methods in this interface only we are using it here. Say add method is there in linked list and remove, and same thing over. However we add the elements to this array list, the linked list also we can add the same data. We can perform this CRUD operations the same way. But there is a difference of the compared to this linked list and array list. What is the difference is you use array list for storing and accessing data. As told you, right, compared to vector also, right, storing and accessing data is faster with in case of array list, and linked list is to manipulate adding or deletion operations that will be happen fast. How it work fast is, if you want to delete, right, then if I delete this, what will happen? This reference to this guy will point to the next node by removing the reference from here and give a reference to this guy. And if you want to add a new element, what this guy it checks that where you want to add the element. If you want to add the element here, what happens? It create a new container, and the reference to this will be deassociate, and the new element will be this pointer will go to the new container, and that container link again you have to point to this guy. It makes, then if you see that the story, this theory, right, may it make complicated. You have to create the link there and pointing to there, but That doesn't make sense that it go fast. It does not happen. That internally it just deassociating the link automatically. System will mean program point to this next one. You don't need to worry how it is happening. It happens within a fraction of milliseconds also. So faster retrieval access, right? Storing, accessing, then you go for a list. If you want to manipulate data, I mean manipulation means adding and deletion, you go for linked list. That is the major difference. Now look at this linked list, and you could see here as we talk about in case of vector, all the methods are synchronized. However, in case of linked list, this is not synchronized. So right? This way we can prove that how you say that vector methods are vector object is synchronized means by default all the methods in the vector are synchronized. So that is the reason the entire object is synchronized. And whereas ArrayList or linked list methods are not synchronized. So they are not synchronized, and those methods, then that object is not synchronized. If this is not synchronized, then what can say that is not a thread safe. Any class methods that not synchronized, that object is not thread safe. Any class methods having synchronized, right, then that class object will be the thread safe. So this is all about list interface and their implementation classes. Now if I have an interview question, they will simply ask that what is a list and what is a array list or vector and linked list. List is an interface, and array list, vector, linked list are implementation classes to the list interface. We can go to any implementation class depend on our requirement, right? Like if you have only storing and accessing, right, only for fast and retrieval purpose and for sorting purpose, then we go for array list. If you want to thread safe, then if you are using multi-threaded environment, then we go for vector. Vector will help you to make the object as thread safe. And if you want to have more updations are there, means frequent updations on the data, then you go for linked list. When the linked list will come real time scenarios in the projects, right, when the user data is keep updating, right, small or more complex data also, right, more frequent updations are there, updation deletions also there. So that case we go for the linked list. That's morely that if it is right configuration data, just read only thing as that, right, just some master data they call it, then we go for array list. When do you go for vector? If you have multiple requests, source, and make sure your object is thread safe, and if we expect the consistent across the number of requests, then we go for the vector class. So these points you have to keep in mind. So when and what collection we have to use, right, depend on the scenario we have to use. You just cannot use just simply that array list. Later you will face the exceptions. What exception is that? First thing, concurrent exception. When that concurrent modification exception comes, when two threads try to act on the same object and that object is not synchronized, and for example array list, if you use array list in the multi-threaded environment, definitely high chances are concurrent modification exception. So that is the reason we have to keep in mind and go for the right collection, go for the right implementation class. So that's all about the list and their implementation classes. In the next class, we see that set, which is the most important object interface in the collection. Right now, we'll stop here and start the new